I'm going to have to watch it on the recording because I didn't make it. But all right. Oh, it's 5 o'clock. I guess we should get started.
Yeah. Hello and welcome to the Jose Working Group. We'll start today's session.
So you're right. User interface. Okay. Hello again. Welcome to the Jose Working Group. The first thing I need is, I sent out an email about 10-15 minutes ago, is we don't have any minute takers. Do we have any minute takers? Please? I did ask you not to make me beg on my mailing list message. People are studiously not looking in my direction. Thank you so much, Phil. All right, so we have a minute taker, and we can begin. Get to it.
You'll have a minute taker in a minute. I don't think there's any hurry with the AI transcript. Just capture important decisions.
All right, so this is the Jose Working Group at IETF 123. This is our note well for the day. This is just a quick request from the knock to the chairs to not, it doesn't really apply in this room because there's not that many of you, but please don't use hotspots. It does interfere with the wireless and they're really hard to track down. This is the agenda. The only comment I would make on the agenda is that we do have, unfortunately, we have some rather bad conflicts this time. So we do have people that are asking me to hold the HPKE piece till the second hour of the meeting. So if we get through David's stuff quickly and the other two, we might move a few of the individual submissions up so that we can make sure the participants in the other have a chance to arrive. So that's the agenda bashing that we have. So we'll need to be a little bit flexible. And those of you who are in the last 3 slots, please pay attention. And with that, David?
Hello, everyone. I haven't actually gotten to attend in person for a while, so it's nice to be back in front of a jury of my peers. So we actually had 2 updates to the JSON Web Proof series since IETF 122. The big change is to single use and MAC algorithms. So we had two long-standing issues. One was the data integrity issue. So the integrity, when you did a presentation, wasn't over uh, your derived issued form, the actual payloads that you were choosing to disclose. It was actually over the protected header only. And this normally wasn't an issue because you're using these single use. You have, the bearer constraints. But there was a possibility that people might try to use this in other applications where they start reusing keys for the holder doing presentations, and it creates weird side effects and caveats there where, for instance, the big one would be that I could potentially claim that they released a payload that I had seen elsewhere into this message, or that they could omit something. So if you're trying to represent things like authorizations with one of these, say you wanted to do a future kind of access token-esque thing where you were trying to be able to downscope the remissions you make on an API call, they could adjust that. So now we provide integrity over the entire message. The way we do this, there we go, is we need something equivalent to the JWS signing input or COSE SIG structure. The challenge there is that we do both. We have a JSON serialization and a CBOR serialization, and it's pretty likely we'll have implementations that only want to have one of a JSON or a CBOR library. So what we did was we created a binary construction that actually was reasonably close to the CBOR SIG structure, but we didn't really define it that way. We just used binary concatenation. So instead of smallest size for things like length, it's always 64 bits, which means that it winds up being, you concatenate this binary value and then your number and then the value you want. So we have kind of a step-by-step flow to construct that. A note saying, by the way, at the end of this, what you actually have generated is CBOR, but it's never transferred over the wire. This is used for signing and verification of what you received. Mac had something similar because we do kind of derived keys, and you may or may not disclose those keys. So it had a similar construction to on the issued form for the signing value. And so we actually changed that to use CBOR as well. So change to those implementations. I see what I'm doing. Part of this work was to solve the second issue, which was that the algorithms used for issuance also dictated what key type and algorithm the holder could use for presentation. So if for some reason you had different types of security elements, one preferred doing P2P6 while the other one only did at 25519, that was an issue. You couldn't really use one of the algorithms we defined. So these are now separate. The algorithm expected that the holder would use is embedded as part of the protected header from the issuer. So the issuer dictates what's valid or not. You could potentially profile this away if you're worried that you might have some sort of increase in supported cryptography algorithms, and these values come from the JSON web algorithm and the corresponding COSE side. Part of this as well, since we were already writing steps for doing that binary construction, we added a bit more step-by-step guidance for verification as well, so that people kind of understood the preferred order of looking at particular pieces of data, that you should probably look at the signature before you start acting on the data within it, things like that. Miscellaneous cleanups, we had some implementer feedback and decided that there was some text to be clarified. We also had some CDDL syntax issues. We had a issue with the text said that you needed one or more payload, but it wasn't clear if that meant that you always had to disclose something on presentation. So we changed the nomenclature. Does it indicate when you issue something, you have to have some data that you're protecting, but you don't necessarily have to disclose anything at all. Part of we did create a plus CWP structured prefix. We took some really long protected header names, proof key and presentation key, that also were a bit confusing for implementers. Part of changing to the independent holder algorithm is that we changed those names as well. So hopefully now they're not only shorter, but a bit more clear when you see them in the text, what they're actually representing. As discussed in the last meeting, JSON serialization was dropped. This didn't have any capabilities defined that weren't in the other serializations. If you have particular use cases that you think would have required JSON serialization, please talk to us. We want to make sure those are handled correctly, but it's more likely this would push for certain information to be outside of the actual JWP presented form if it's supplemental, like some sort of co-signing. We also talked last meeting about parameter unification. Since Jose and Koze are spiritually similar animals, but actually are separate ecosystems, you have weird cases where they're not really interoperable. One would be as simple as referencing keys. One is by binary, one is by string. This means some key IDs on the Jose side actually wind up being URIs. They may even say this is, for our application, this is how you go determine what this key is, or it's a thumbprint. It's binary on the Koze side, and it'd be very unclear whether that indicated that you could stuff UTF-8 in there, or you had to base64 code it without the application actually dictating that. So outside of application guidance, there's not really a clear mapping between these headers. Same thing with claims. Some are registered in one place, some are not in the other. The CWT claims registry talks of JWT claims by name that are actually in the JWT claims or defined in those specs. And sometimes they're registered with different definitions. So under RATS, the nonce claim for CWT is pretty highly structured and variable. They have a different name for it under JWT, but it gets a little bit confusing. So the question was, is this something we had to solve? And I don't think there's sufficient input. I don't think that's really within our charter, as it were, within this document to grow to solve that. So it's something we would like to be solved, but right now, even though they're referred to as serializations, JSON and CBOR are somewhat divergent. And so it's expected that the application will probably either define how to express in both or have an expectation that you always will use one or the other. Underneath all this, though, the signature algorithms still operate on binary data, so they're identical. Treatment of parameters and claims. So this is elaborating. For the protected headers, we have our own new registry. This is separate from the existing ones used in Jose so far and Koze. We are strongly recommending anything put there have definitions for both JSON and CBOR. And then depending on if you're using JSON or CBOR proof tokens, we reference one claims registry or the other. Just kind of going into things we're exploring right now, BBS extensions. This is blind signatures per verifier linkability. These have been accepted, and so we're starting to investigate how to best map these into JWP, how much value we can get out of these. We suspect there will be use cases that want to use these. So this is being tracked in issue 181. Another one, there's a presentation at CFRG. Unfortunately, I'm going to have to cut over there. anonymous credentials from ECDSA. This is pretty interesting work that we knew was possible, but time-wise and CPU and resource utilization we think was feasible. So they're looking at taking JOTs, SD JOTs, MDocs, and doing zero-knowledge proofs to release data about them. So issuer uses traditional signing algorithms and can use a traditional HSM. They don't have to use something like BBS, but you still have unlinkability on the presentation. They have a significant amount of complexity dealing with those formats. One of our benefits is that algorithms really are operating on binary data. And so we can do a lot of optimizations potentially to reduce the complexity of those circuits, reduce the memory usage time, the size of the message, which can be like 400K to a megabyte for one of these proofs right now. So it's early discussion. I'm kind of hopeful that we'll be able to come up with something there. And so do we have an algorithm? One consequence of this for people who aren't familiar with zero knowledge circuits is they're kind of like applications. So you would define this is the circuit that you run on this type of document to pull values out and make attestations about them. That circuit would probably be part of the spec. So understanding that requirement that these might not be a little bit more application specific, understanding what we can do with those, but it's kind of exciting. Another one talked about today will be Sigma protocols. This is kind of the first work I've seen in the IETF. There's not quite enough there for us to compose a solution for JWP, but I'm really interested in seeing where they see this going in the future within the IETF, additional complexities and combinators that they have that you might be able to build a more complex proof. Opportunities for participation. The CBOR representation is relatively new. We'd love to see more people implementing around that and give us feedback, especially people who have worked with CBOR and kind of understand that ecosystem a little bit better. And we're always looking for more cryptographic algorithms. So this would be the ECDSA-based EKP that there was a talk about earlier, things that let us issue post-quantum safe messages, things to that effect. And we're starting to get some implementations, so we'll be looking to do interrupt testing. So the questions are, what use cases people have, and what would you like to see us do next? So,
John? Oh, sorry. Go ahead. You ready for questions? John?
A couple things. On the Google zero knowledge proofs, ZK snarks, that's not, your slide kind of tied it to ECDSA, but it's not tied to a particular signature algorithm. So one of the advantages of that may be that it could be post-quantum safe. The other is at least the WW Wallet project as part of the German SPRIND EU ID stuff. We have implemented at least our interpretation of JWP, which we have hardware support in at least a version of YubiKey for doing the BLS signatures. So we are experimenting with that. I believe Emil has made a long GitHub response around metadata and some of the things that need to be considered around metadata when you're actually using these for verifiable credentials. So we would also be interested in anybody that wants to work with us on the verifiers and issuers for WW Wallet. There's Emil. I don't know if he has anything more specific to add. He's the one that's done the work.
Yeah, I will say mostly it's been straightforward to apply GVT or JPTs, I think. What I've done so far is essentially just mimic the JWT things we had in W Wallet and just replace the cryptographic bindings with JPT equivalents. And that seems to work well enough for now, as a prototype at least. So at least the mapping between JPT payloads and stuff like that is straightforward enough, as it just, the JPT specs just forward to the JPA specs. The main thing that I have encountered is there's a lot of nuance in mapping claims to payloads. So I've been working on BBS specifically and how you do that. And I've written a long monologue on the issue tracker about that. I don't know if anyone's seen it, but yeah, I think there's a lot that could be discussed, but I don't really have any concrete thoughts on that other than it's complicated.
Yeah, I appreciate your feedback so far, and I'll make sure I take a look at that later today. John, to your first point about the ECDSA over, it doesn't require use of that particular algorithm, but it's optimized for it. And you're having to do the cryptographic verification within an arithmetic circuit, and that adds a certain amount of complexity for switching that algorithm out. So it's possible, depending on which algorithm they move to, it might actually be significantly simpler. Not being a cryptographer myself, I can't judge how big or small that would be, but it's not necessarily for free unless the algorithm just happens to really line up well with running in arithmetic circuits. The post-quantum guarantees that has, as well as BBS, are during presentation that you won't leak additional information through a post-quantum process. They can't look at the presentation you gave and reverse it and get additional information. It doesn't help you with them compromising the issuer key and issuing arbitrary credentials. But if I capture a presentation and look at it later, I'm not going to be able to squeeze it for additional data that wasn't meant to be disclosed. Anyone else?
You're muted, John.
So I have talked to them and may have been the one that suggested that they look at JWP. The the thing is that the formats that the data formats they're using, trying to reuse MDoc, etc., are about as inefficient as you can possibly get for those circuits. So there are potential benefits of having something that they can calculate the circuits over that might not be tied specifically to as tightly to the optimizations that they had to do for ECDSA. So there are a number of different advantages that we could get increasing the efficiency of those circuit-based methods if they didn't have to be done over an existing MDoc or CBOR type format.
Yeah, and elaborating on that, the circuits I call them programs, but they're a little bit closer to designing a hardware ASIC. They're really low level. So processing something like CBOR where you have length prefixes actually does add a significant amount of complexity. Even the base64 encoding within a JWT adds a lot of complexity. So we have a bit to offer there because we do leave the algorithm somewhat abstract. It's not really, we don't really go through an encoding first. Even the earlier definition that I described as CBOR construction, it was specific to those two algorithms. So there's a lot of particular optimizations an algorithm can do to try to optimize its performance. Okay, thank you.
Good evening, everyone. I'm Thiru. I'll talk about the updates to this draft. I think we have just 2 pending issues, and I seek inputs from the working group to resolve them, and should be soon ready for working group last call, I believe. Yeah, so the 2 main the feedback that we got was regarding updates to the inputs to the context in the key derivation function and whether to use OKP or AKP or something else. So I think the second one needs some help from the working group in discussing what we need to do there. So based on the inputs, we are using a KMAC to basically derive the final secret for encrypting the key encryption key or the payload. And the parameters have been reduced to the algorithmic ID and the public info and private info. Public info is nothing but the key length, basically. So what the parameters that are excluded are party U info, which is basically PQChems do not support authentication for sender. So that's the reason there is no point in adding that, because there is no cryptographic binding that could be provided. So that's got excluded. And party V info is excluded because the recipient's identity is already bound to the public key used for encapsulation. That's the major change to the KMAC. I'll take questions at this stage to see if this change is acceptable, or you want to see more parameters or remove any of them.
Good afternoon, this is Philip Kokan. If you could remind me, 7518 is JWE. Okay, thank you. 462 is ECDH, and we're using only a subset of it. So I was wondering, since in ECDH, private info is set to be an empty,
Yeah.
It's set to be an empty octet. How is that dealt with in this draft?
So this draft is basically saying that if the peers have out of band negotiated the private info, right, they could set it. Otherwise, if they have not negotiated, it will be set to an empty string.
Okay, so is it says it's a subset of the Jose context specific defined in JWA, but then it has different behaviors than in JWA.
Yeah, that needs to be fixed. But I think
could we maybe pluck those things out and just define them specific to Chem, so that we don't have to chase around ECDH specific paragraphs.
That makes sense.
Yeah.
I can do that.
Thank
you. Yeah. Yeah. So the second one is, it looks weird that we are using OKP, right? The reason why we picked OKP, if you give me a chance, let's finish all the slides and then I will take comments on this one so that we understand the context of using OKP, right? So the current spec uses OKP, which the curve is basically the Chem algorithm identifier. For instance, it could be MLChem 768. And then the public key and the private key, currently RFC 8037 says that it is not specific to ecliptic curve, but it sounds weird to have for someone looking at it without reading the specs that, hey, why is the curve carrying MLChem? It does not sound like we are doing the right thing, right? Then the alternative is, hey, why not use AKP, which is defined in Causa dilithium, and earlier we were discussing of picking that up. But the whole idea was that it uses the ALG parameter, which does not have any problem with digital signatures, but it's not ideal for chems, basically, because if you look at this example, you would have to say, depending on the mode that you have, either it's MLChem or the GCM algorithm that you're using for encryption, which basically restricts the use of the same key for multiple modes. And we have not seen such a restriction exist for traditional asymmetric algorithms. So I have 3 proposals, basically. One is that should we continue to use OKP, or I think the easiest way I would say is define a new key type and don't have to deal with this dilemma, right? But I would like to hear from the working group before I make these changes to the document.
Hello again. So you're talking about continuing to use OKP, where in fact up until 2 weeks ago we were using AKP. So we're already sort of assuming that we've agreed to use OKP when I don't think that was necessarily the case. You talk about that the fact that you use that we could use AKP introduces ambiguity, where in fact it removes it, because it would imply that you can have a single JWK only usable for a single algorithm. That is, by definition, removing ambiguity, not introducing it. The nice side effect of this is, since AKP has algorithm as required, it's part of the key's thumbprint generation. Ergo, you could easily, if you so wanted to, because you have the key in HSM, you can expose the same key twice. It's going to have a different key ID if you so want to reuse the same key and save space in your HSM. I don't know why. So that is sort of how I'm looking at it. As an implementer, I try to explain that on the list, but I don't think having the same JW key, JSON web key usable. Brian, stop laughing. Come on. This is hard. I don't think the ability to have a single JSON web key usable for 2 modes has proven to be useful or needed. So unless somebody comes in and says, yes, we need this for reason X, I'm willing to budge on this 100%, but I think it actually introduces complexity into the implementations, and it's not necessary. It hasn't, at least from my perspective, proven useful in the traditional asymmetric algorithms that we have today.
Okay.
Hi, Daniel Havens from Proton. I am the Web Crypto API editor, and I send the same thing on the list, but very last minute, so I'll say the same thing here. So what I noticed is that when exporting a JWK, an MLChem JWK, the Web Crypto API doesn't know which algorithm to put, right? So in the current draft, I just wrote to put the first one, like MLChem 1024 in this example without the key wrap, but actually like the API doesn't know which one it should be, right? So I can see the issue with using AKP, but also, as you say, like using the curve registry and value just looks very strange, right? So I would tend to also think, why not just define a new key type, let's say chem maybe, and define another sub-value that specifies which chem it is.
Yeah, I think if you define a new one, right, we can make ALG optional, and if people want to tie it, then you could add that or just skip it out. So that way, right, you have all the flexibility to do what we want.
Sorry to jump in. That would only solve the optics problem of using curve to define the
no, I'm
the
saying
ML
that
algorithm.
we will still have ALG, but it becomes an optional parameter. So
yeah, so the only thing that it solves is the optics of using OKP, because otherwise the key is effectively the same, just different parameter names.
Yeah.
Thank you.
Yeah, so the application will need to somehow define or decide like which algorithm it actually is, right? Which maybe is what you want in a way. But yeah.
Do you want like to hear from the last one, right? So do you want
Sorry for laughing. I was laughing at your mixture of acronyms and terms because they're hard and it's easy to get wrong. But I think I very much agree with the AKP in the context of key agreement or encapsulation only being able to apply to it's not a, I guess I would say it's not a problem. Like, I don't see that as being a restriction that anybody cares about. So we shouldn't be trying to solve it with a solution by changing a bunch of things, I guess. There may be, I don't understand the Web Crypto API problem as well. Maybe there's something there to look at, but this is not an impetus for changing the key type or not using AKP, because it's not a,
At least I heard otherwise from one other member in the working groups area, I believe, who said that he does not want to use AKP. So that's the reason when Philip raised this comment in the mailing list, I said I wanted to bring it in the working group discussion. We can take it back to the mailing list just for this topic and hear all the opinions and make a call, because I don't want to jump the guns and make the change and again keep revising this one.
okay, but you did do that.
Yes, and I said I'm going to bring it back, right? Yeah. Yeah. That's the one basically. Do you want like hear opinions from the working group, like, or we'll take to the mailing list?
Yeah, I don't know. It seems like we have gotten. It seems tricky. Do we have any more comments here? We have already gotten comments. Should you continue discussing on the list, or is it something we can resolve with a poll? I don't know. It seems to be disagree.
So are you specifically asking for a poll, or do you want to continue this on the list?
I can take it on the list, but if it'd be great if we can do an initial poll just to sense.
Do you get an initial poll
Yeah,
now?
yeah.
Okay.
Yeah, but in spite of that, I'll take it to the one just to hear what's going on.
Maybe you could meet after the meeting and discuss in person.
Sure.
It seems.
Yeah. I think that's about it. I think that is the last issue. If you could resolve that, I think. Yeah.
All right. You have 30 seconds vote. I'm assuming everybody has their, and ignore my typo. Um, I think that, excuse me? That's what I said. Ignore my misspelling.
I was just thinking about.
No, I was typing quickly, and then after I hit return, I saw that it was a mistake, but hey, I think that's close enough. You got some feedback.
Yeah. And the other one would be, should we use AKP?
Okay, you want the other one too. Did I misspell it? Oh. I can tell this is a subject you all are deeply passionate about. Is that adequate feedback for now?
Yeah, but I'll post a mail to the
Yeah,
working
post to
group.
the mailing list
Yeah.
and we'll go from there.
It's not helping.
It's not helping. The next agenda item, I just wanted, I put it on the agenda to ensure that we didn't lose track of the document. And then I saw just after I put it on the agenda that there has been some email traffic on it. Do we want to discuss the deprecate none topic? What's the next steps planned for that document?
I promised to do a review last time and haven't done it.
Okay,
I'm sorry.
that's all right.
But generally, I think it's, last time I looked at it, it was pretty good.
Okay, because there was no updates for a while, so as a working group document, we want to keep it progressing.
Maybe not relevant. I know also the author is in the midst of some employment complications that may be
Impacting.
yes, his ability to do things right now. So just be aware.
All right, thank you. All right, so we are now at 20 till, which means I still need 20 minutes worth of agenda items before we move to the HK, the other one. So do you want to do, go ahead, Mike.
Sure. I was asked to do a review of the deprecate none RSA document, and I did so this afternoon, and it went to the mailing list.
Yeah, I saw it come on to the mailing list. I just, like I said.
The substantive stuff in the document is okay. There's additional references for context that he should provide.
Thank you.
Yeah, this one I'll talk about the work happening in HPKE with regard to PQ, and then how the current Jose HPKE draft can be updated to support hybrid chems. Okay. Okay, thanks. So there are two parts for migration from traditional. One is that it could directly move to PQC Chem, which we just discussed, or if someone has a conservative scheme and wants defense in depth strategy, they would want to use a hybrid one, which uses both the PQC Chem and the traditional one, combine them in a way that you could get a final shared secret, right? And we have not asked, I think we've been waiting for progress to happen in the HPKE, the newly formed HPKE working group. And the HPKE PQ draft there has made good progress. It's already in working group last call, and it basically defines how to combine both the traditional and PQ algorithms to have the final secret. It's eventually relying on the work happening in CFRG working group, which is also made good progress. So we have already updated the draft to align with the HPKE draft, and we have already addressed all the comments we have received so far, and we pretty much align with the Jose and Jose HPKE drafts, and we plan to align as more changes come in. So it's basically, for instance, HPKE 9 within base mode is the only mode that's supported. So you could mix X225519 with MLChem 768, and the key derivation function would be shape 256, and the A8 algorithm could be a 256 GCM. So this is all like what is being done in HPKE, and we're just leveraging that here. So I don't have any pending comments, and I think this is an eventual transition to the work happening in HPKE. So I would like to request working group adoption call at this stage now that both the COSE and JOSE drafts are in working group last call.
Any comments? Anybody have any thoughts on whether we should do a call for adoption or not? Surely that's something pretty straightforward. If we did a working group call for adoption, who would review this document?
The hybrid one?
Hybrid.
Okay, that's what I thought. I believe the last time we discussed this document in the working group, there was a decision to put all of our effort in HPKE into finishing the Jose HPKE spec before taking on additional HPKE work. So, you know, depending upon what happens in the next hour, we may be on track to do that pretty soon. But I wouldn't advocate taking on more HPKE work in this working group until we figure out what the formulation of our normal HPKE work is.
All right, that sounds reasonable. So
Yeah,
can you just
thanks.
come reconsider after we resolve the other one? Okay. Designated verifier. Yep, you're up.
Yeah, sure. Is that right? Yeah, good. Trying to put this in the right height. Oh yeah, so I just talk about a new proposed work item that has from the beginning been created by Paul Bastian and Mitja Kraus, and we added new editors, which is me, Stefan Santesson, and Peter Altman. Next slide. Yeah, well, I have my own slides here. So what happened with this is that this was something presented at the IETF 121, and it was motivated by enabling repudiable signatures. And what happened since then is quite a lot, actually. The same thing is we wanted to be able to use HMAC signature for signing, but it's no longer claimed to be the designated verified signatures. That is a term that is used to describe something a little bit differently. So a name change is about, but the goal of this is still the same thing, is able to use HMAC signatures, but derive the key from a public key, which is what we normally do in signatures, is that we provide a public key and we want to be able to verify that signature based on the public key. When we use HMAC signatures, we have a shared secret. So can we make this level in terms of allowing verification based on a public key and derive the shared secret from a public key? And that's the building motivation behind this work. So this is just about one of the key motivations that has come into our path that made us expand the editors also to me and Peter, because we came to this into the European wallet, where we use SDJOT as a means of providing verifiable presentations. And in the SDJOT, we bind the presentation of this to a presentation key, or which we can have the blinded client key pair T. So what we have is a wallet that possesses a key pair that is bind or protected by an HSM, which is the key pair C, big C. And then we blind that in the SDJOT presentation, the confirmation key, by adding a blind to it or multiplying that public key with a blind. So when we present that, we need to prove, the wallet need to prove that it possesses a secret T. So if we use ECDSA, for example, to do this, we have to do the manipulation of the private key inside the HSM, which means we can use standard technology here. With HMAC signatures, we can do that blinding, addition, or multiplication outside of the HSM, which means that we can get away with using standard HSMs. That's a very, very nice win if we can do that. That's why we're very interested of using HMAC signatures, but we still need to be able to go from a public key to a shared key. So basically, yeah, I just said most of these things is that it's relevant in the EIDAS. The EIDAS specifications have two different formats for verifiable presentations, which is SDJOT and MDoc. MDoc has specified how you can go from a public key to a shared HMAC key, and SDJOT has not. And then we first proposed to SDJOT that how we could specify that as part of SDJOT. That was pushed back on that, understandably, because they were very close to finalizing that document. So instead, we thought it could be a separate specification, which is this draft then. So there are two approaches, one that is in the current draft and one that is possibly replacing that. And I have to reveal that I'm a fan of the second version, the changed new version of it. And we seek sort of the guidance from this group here, which one is the one that should be used. So the one that is currently being specified in the draft is that we specify a new algorithm for every version of doing this. So example, that could be the, it's very, very unclear on the, it's clear on the screen, but very, very not visible. But the alg parameter that says DVS P256 SHA HS256. Then that specifies exactly how you would do the derivation of the key, and that's specified by the algorithm name. For every new way of doing this, we would specify a different algorithm name. And so then as part of the other header parameters, we can then specify the key of the recipient and the key of the signer, and then do the derivation based on the method that is defined by the alg parameter. The other way of doing this is, and which is the one that I would like to pursue personally, is that we keep the HMAC signature algorithm names. So we are specifying to use HS256, HS384, or HS512. But we define a new header parameter that specifies how you derive this shared secret from the public key. And that would have the advantage of allowing us to use existing tools that can do HS256 or HS512. And we can then do the key derivation outside of the standard tool and then feed the shared key into the standard tool, and that would work perfectly fine. Basically, that would look something like this. Also extremely non-visible on your screen here, but The alg should then stick to say HS256, and then we would have a parameter. We call it now PKDS, which is public key derived shared secret. And that specifies all you need to know how to derive the shared secret from public key information. And then you can use that to verify your HMAC signature. So those are the two different approaches, basically. If you compare them, it's like, yeah, to create your own new algorithm names is more flexible, but it's also have the problems of not being compatible with current tools. If we keep the algorithm HS256 and others, it's less flexible, but it's also more compatible with existing tools. So those are the two options. We should select one of them. And if you agree that this work should be done at all. And that's sort of all information. There is links here to the work and where you can provide comments. And otherwise, I wonder if you have any comments here, or that's the end of my presentation.
Mike Jones. I think I prefer using the existing algorithms and then having a method to separately derive the key used for the separate algorithms. That seems like we will have less sort of duplication of work.
Yeah, that happens to align very well with my opinion as well.
Perhaps unsurprisingly, I'm of the complete opposite opinion. Sorry.
That's good.
Reusing the existing algorithm is only going to lead to issues like we've had with RSA signature stripping by replacing the algorithm and then changing the signature to the representation of what the key, what the public key was, and now all of a sudden you're going to have signatures which were meant to be with different key replaced by one that is just a representation of, I don't know, let's say the actual header that you've provided, just serialized to a string. We seem to have gone on the road of fully specified algorithms. I don't see why we should have something different here.
Well, if I would voice my opinion on this, and the co-authors are also listening here, so they can join the queue if necessary. But I feel that if you do a verification using standard tools for an HMAC signature, you have to present the JWS and you have to present the shared secret. That's two parameters. So what you would do when you see something like this is that you, of course, need to pre-process the header parameters to put it into the verification. I don't see that as a violation of using the current tools. I don't see the problems. But if you have that, if you see a problem of that, I think just if you could go in and raise an issue and we could discuss it on the GitHub, that would be great, because we can't foresee everything. Yeah. But right now, I don't really see the problem.
Off the top of my head, the input to HS256 validation is a random set of bytes. It's a string, yeah, and not an elliptic curve key. So just for example, an implementation perspective, now I have to deal with two different types of input for the same algorithm, which is never good. It was always a bad idea to accept strings as elliptic curve keys, same as for symmetric keys.
Yeah,
it was the case for RS256, and that's where RSA signature stripping, I don't know what it's called in the JWT BCP or HOSE BCP. Maybe somebody knows. There was an attack where you just change the algorithm in the header to HS256, and then it validates with the value of the public key verbatim. without actually being represented as an asymmetrical key. So I fear that this could lead to the exact same problem. But as you said, I will raise this on the list. That's okay.
That would be very appreciated. Thank you very much. Yes.
Hi, Ori Steele speaking as an individual. The blinded key piece, like, I'm trying to understand the relationship between the keys and the confirmation method. There was a presentation in the Whimsy working group this week, and they talked about how they had made the algorithm in the confirmation key mandatory. And so I'm trying to understand what the algorithm in the confirmation key is for the SDJWT claim set that you're presenting with this signature.
So what's written into this draft has absolutely nothing to do with the blinding stuff. So the blinding stuff was just something that led us into being interested of using HMAC signatures instead of ECDSA.
So that's all internal. It's not part of the claims
No,
data model.
it's not part of this at all.
Okay.
So the only thing this draft is dealing with is how to derive a shared secret from a public key pair. So you have a key pair of the verifier, a key pair of the signer. How do you, by this, derive a shared secret that's used as a HMAC signature key?
You're doing selective disclosure presentations.
Yes.
So you have two keys. You have the issuer's key and the holder's key.
Yes.
And the key agreements between the holder's key and the verifier.
Yes,
correct?
yes.
Yeah,
So
the algorithm in the holder's key is a key. You're doing key agreement between the holder key and the verifier key.
Exactly.
Okay.
So in that case, the algorithm would be HS256 if it's alternative 2. And in the header parameter, you would specify which verifier key is used and which signer key is used.
So
and then you derive the.
But I think, putting weight on the whole fully specified algorithm and disclosure, I work with Mike on that. I think the holder key, if you were to make it the algorithm mandatory and you wanted to be able to switch on this kind of signature scheme, it's the key agreement plus the HMAC signature that you're doing with that holder's key. And the issuer is saying, this is the only key, this is the only algorithm this holder should use to present these claims. I don't want this holder to try and present claims with a weaker algorithm or some other pairing.
Yes.
Thanks.
Okay, thank you.
Couple of maybe not super well-formed thoughts, because I've only been thinking about it for a minute, but I've also been thinking about it for a long time because we've looked at some of these issues through discussion in SDJOT, and I've looked at some of the prior stuff of that Paul had worked on with the DBS pieces. We've discussed that you can kind of do this at the Jose layer with a new full algorithm, and that potentially you can do all of it above at the application layer. And I recognize preferences for doing one way or the other, but the approach that you've outlined here, the sort of your second approach, feels to me a little bit, and this is the part I haven't thought about a lot, so bear with the rough language, feels to me like kind of the worst of both worlds. Like, choose one or the other, but you're mixing application layer constructs into the JWS, or pushing algorithm constructs up in the application layer. It doesn't feel like a natural fit. And problems like the one Philip mentioned, thinking about it from like the API layer and who gives what key and who does what pre-processing, it does feel like it potentially opens the door to that kind of thing more. So I'm not sure what to do with that. Maybe that if you want to go that far, describe how it works, how you would do it at the application layer prior to invoking JWS, or stick with what you got here. But this does give me the.
Yeah. So if I interpret what you're saying is that you would like everything you need to do to be given by the algorithm parameters, so that I don't have another process in the application layer that needs to be done first, and mixed into what I feed into this standard verification algorithm.
Well, I think I'm saying that if you're going to have that pre-processing and
Yeah.
feed it into the algorithm, then let it be that. That's completely out of the remit of the JWS and the JWS algorithm.
Yeah.
If you're going to have it be something happening at the Jose layer, the JWS layer, then go ahead and do that. But this feels like right in the middle and kind of doing both and neither at the same time.
I see the validity in that comment. So I think we should take that into consideration as well. As it could be a good argument why you would actually define unique algorithm identifiers instead of having the standard H's. Yes.
Yeah. And I think just to nitpick a little bit, like I understood what you were saying about compatibility, this and that, but it really depends on the lens you want to put on compatibility.
Yeah.
So depending on how you want to look at it, either one is or isn't compatible. And you're going to have to do something pre-processing at the application layer that's not compatible.
Yes.
It would be very compatible if you had a well-defined, understood, implemented algorithm at the Jose layer. So
Yeah, the idea is that a tool that would be a future tool would have to understand this header parameter and then automatically do the key derivation based on that and feed that into the verification process. And I'm not sure, I mean, now when you bring it up, it makes me a little bit uncertain that it's actually the best path, but it seems like this would be a faster way of being able to use standard tools, but it may also be the worst solution long term.
Yeah, I understand. I can see the impetus of the thinking there. As a tool offer myself, it makes me worried both in the near and the long term, where some of the other solutions just make me worried in one or the other.
Yes. Okay, thank you.
Phil Armbaker. Listening to the discussion, I'm reminded of the fact that signature is rather fragile. And I think I'd like to see there be one way of doing this type of thing. I mean, it's kind of like a gut feeling more, but I know that when we tried to do the threshold signatures, a lot of people got burned by trying to do things with ECDH signatures that were not quite within what was thought about.
Yeah.
And while I can't quite think about how this could interact, I'd be much happier if there was one or two reviewed ways, a constrained set of paths seems to be happier than having a mix and match.
I share the view that we should have in practice one or very few ways to do this. But I also support the idea that if you need to do it some other way or change the algorithm in the future, there is an extensibility and agility path to do it. But normally there should only be one in practice.
All right.
Yeah.
So further discussion of the mailing list, no call for adoption or anything like that?
Yes, only call for adoption from what I'm concerned, yes.
Okay, great, thank you.
Thank you.
Brian?
A lot taller than me, Stefan. I knew that, but when the microphone hit me in the head, I realized just how tall. Right. I wanted to talk a little bit, provide a bit of perspective on the Jose and HPKE work. So thank you for giving me the time to talk at you here for a minute. Providing a little bit of perspective on where my perspective originates. I developed an open source implementation of the Jose suite a long time ago. I lost track of how many years, and it's written in a very unpopular language these days in Java, and it's probably the 4th or 5th most popular Java Jose library out there, which is you know, very. That was supposed to be delivered with like humor, because that's not very good. It's not that popular, but it is used in a lot of the products of my employer, Ping Identity, and as a result, it's used in a non-trivial number of the global 2000 corporations. So it's out there, it's used in production by very serious companies that expect a level of seriousness and security from their products that I aspire to provide. I don't always live up to it, but I aspire to it. I was also thanked twice in the Jose Cookbook document, once for reviewing it and once for actually verifying the compact serialized examples with that very same library. I say this not to brag, I hope that's obvious, but to say that I do have some skin in the game on this stuff. The impacts of the work produced by the Jose working group will eventually impact the implementation that I work on and impact the customers and people that depend on that to do things that are security related. And that to me is real. I have some real skin in the game about what happens here. I also actually really care a lot about the standards that we've developed over the last 10, 15 years within this area. Jose, JWE, JWS, JWT, JWK, and JOT in a different working group, but very closely related, have proven to be extraordinarily useful to me, my employer, my community. And I have enjoyed using them. They're not perfect, but I think they're really valuable. I think they're worthwhile. So much so that when some very significant criticism of the technologies emerged, I took it upon myself to put together a conference session talk that I called Jot or Not, because it's funny, and try to give a very balanced, rational view of both the criticisms, whether they were warranted, what could be done about them, and touch on the subtleties and the difficulties of it. And this particular slide was from that session. I screenshotted myself on YouTube here, but this is a bit of an ad hoc collection of some of the actual commentary that was made on or against or about, mostly about JOT, but JOT out in the world outside of the IETF oftentimes get used as a synonym for the entire Jose suite, because that JOT is that to them. And you can see some of it is not good. And I tried to look at this from the perspective of, where did these come from? Are they legitimate? How can they be, mitigated? Mitigated is the wrong word, but like, look at the realities of it. And the truth is, mistakes were made. Some great things were done. It's a mix. But one of the sentiments I found also when doing some of that research was one person was, this is a direct quote from somebody, not me, but reading the archives, I found that people raising many of these classes of concerns and being brushed off. And there was, I think, legitimately feedback early on in the development cycle of some of those standards that pointed out potential problems, likely potential problems in the work. And the working groups here did not listen to them. And I think that's a problem. I know you can't listen to everybody, but I do think it's a problem. And I think it bred a bit of resentment that damaged the reputation thereof. It gave people the opportunity both to feel bad, because it feels bad to be brushed off, and to point back and say, look, I told you so after the fact. I'd like us not to repeat those mistakes. One of them was alg none, the non-signature signature algorithm for JWS. Even in the scope of its development, there was an opportunity for not even an outsider, but an insider to correct that mistake. The area director at the time during the review said, this is a really bad idea. But there was some internal rallying to get people pumped up and to defend the idea. And even here, I'm quoting myself, it's too small to read, I know, but I and others jumped in and rationalized why it was okay. And I actually think I said some, rarely for me, said some articulate things explaining why we should include this that made sense even. The problem is I was totally wrong. And to this day, we live with the impacts of that mistake, both to people who've had their systems compromised, to the reputational hits it's taken on this whole thing. Even within the IETF, there are people that think JOT's bad because of the alg none vulnerability. There's reasons it's good, there's reasons it's not good, but it's earned a reputation in some people's mind simply as a result of some of these mistakes. And I would like to do better. And that brings us to Jose HPKE. We have a standard 7516 that defines how encryption works with the compact and JSON serializations. It's JWE. It defines what an alg is, and it defines how to use it and what it does. It's kind of like, it's a framework specification that defines the JSON web encryption framework and provides alg as a pluggable agility piece to plug in different encryption algorithms. Alg happened to be defined in JWE as a way to do, I'll have to read it, sorry, my eyes aren't good. It's key establishment, but the words identifies the cryptographic algorithm used to encrypt or determine the value of the CEK. There's not a lot there, the CEK being the content encryption key. So alg gives you the placeholder for an algorithm that determines somehow the content encryption key. Turns out we have ways of doing it. One is just pass it through directly. There's RSA key encryption, there's ECDH key agreement, so forth and so forth. Anyway, and then we also have some things that based on that definition describe how to actually perform JWE encryption. It's cool, it's how a spec works. It ain't perfect. I think people would do it differently in a lot of ways today, but it actually worked pretty well. And amazingly, you could do public key encryption with a hybrid bit of symmetric encryption even back then. That was me being facetious, but it was one method of, there was a hybrid public key crypto system built into JWE. It worked a little bit different than the current HPKE, but it existed. Anyway, what we have now, HPKE, JWE, integrated encryption, those words, sorry, there's a lot of prerequisites. It's hard to follow on, I only have 10 minutes I've already wasted. Blatantly violates all of these. It just does. Doing the whole key agreement encapsulation and content encryption process is not encrypting or determining the value of the CEK. It's not. It's not. Now, there is something like that going on inside of the algorithm under the covers, but that's not what the algorithm's doing. Somewhat less quotable, but still true, is having completely divergent behavior conditional on a completely different parameter doesn't really fit and undermines many of the benefits we're striving for with more fully specified algorithms. So in the current draft, we have integrated encryption and and key encryption. There's reasons for having both, but the algs are the same. That's really problematic from both implementation perspective, depending on your design. From my implementation perspective, it's really bad. and from the kinds of things signaling who supports what in metadata or other negotiation mechanisms. When you have one thing that means two things, it makes it very hard to negotiate in a way that you actually know you can count on, because you might think it's one thing, I think it's the other thing, we agree on it, and then it doesn't work. Another area we have in the HPKE, JWE integrated encryption, excuse me, also, I'm off track here, is really problematic with respect to its E and C mode. So in JWE, that specification we produced about 15 years ago, we have the E and C algorithm parameter. It's a hard one to pronounce because E and C is encryption, but it's an encryption algorithm, and it's actually the content encryption algorithm. So after you do the key agreement or key negotiation or key, whatever we called it, the output of the alg is basically the key. You've agreed to it, you've encrypted it, whatever. You take the key, that's the CE key, CEK, and you perform AEAD encryption, content encryption on it, and then you do the rest of JWE. We have a definition for ENC in 7516, and then we pulled one of the processing points, which basically says, here's what you do. You take the content and the CE key, CEK, and you encrypt the content with that, and then you take the AEAD parts and you put them here and there. So the integrated encryption mode in HPKE, JWE also violates all of this. INT, as it's recently-ish been come to be called, as a contracted encryption algorithm, performs no encryption whatsoever. This absolutely does not conform to the normative requirements of 7516. I have said it's dangerous and irresponsible and drawn parallels to alg-none. Some people have pushed back on this, that's fair, but I do want to point out that in JWE, alg-dir with an AEAD content encryption algorithm is often, well, sometimes used to provide confidentiality and integrity. So if you could perhaps trick an implementation into accepting alg-dir and ENC int, you have roughly the equivalent kind of signature bypass mechanism, an integrity bypass mechanism that you do with alg-none. It's not exactly the same, but there's a lot of similarities, And so I admit here that maybe that's just me being a little bit hyperbolic. It might not be that bad, but it looks really similar. And so far, the defenses of it that I've gotten explaining why it's actually okay is that it's such a violation of the expected architecture that that won't be possible, because you have to have such a fork in your code and treat it as such a special case that this kind of bypass won't be possible. That may be true, but to me, like, that smells of bad engineering, and bad engineering shouldn't be your catch-all protection for security. So 1 minute, okay, wow. Can we do better? I don't know, maybe not. I've tried and we haven't gotten very far, but I think it would be really unfortunate for numerous reasons. One, reputationally. Personally, working group, IETF broad, feels bad to me to do that. Later stage reviews might potentially see some of the things, same things I did, and push back. So that would mean changing things later that could have been changed earlier. Maybe the designated experts, when they look at the registry asks, will see the same things that I did and say, perhaps integrated encryption is not an AEAD, so you can't register it. And we might be scrambling them to make changes that often, when you do it that late in the process, they often don't work out very well. I know it doesn't sound good, but the reality is when you make changes later to fit specific feedback, they are often less clean than when we might have wanted. This is a quote from the mailing list. This whole conversation, I think, was Ilari said it should be conditional on deciding if to support IE at all in JWE. Note this is not, IE is his acronym for integrated encryption, not Internet Explorer. I do want to thank Simone for that photograph there. This, I think, is a very underappreciated option. Without the integrated encryption mode, that's where all the problems that I've identified come from in this space. You could do key encryption and just be done with it. Now, admittedly, that kind of misses at least a lot of the perspective benefits of HPKE, because you're adding this additional key wrap and then encryption stuff when you kind of don't need to, but I think it's worth considering. We could do JW HPKE, it just rolls off the tongue. In place of IE, some kind of Jose-esque JSON and compact serialization specifically for HPKE, unencumbered by the constraints and constructs of 7516. Just have a thing that's dot, or I don't know, maybe squiggly separated, that has an alg, and that thing is an HPKE JWE or something. You could call it a JWE. And have the pieces make sense and the algs make sense, and it all just kind of fits together. It's not that simple, but it's actually probably pretty simple. And you could still call it a JWE, and it could still work in the constructs of JWE or JWT, where a lot of the impetus of doing this work to be able to have it drop in for JWE and JWT use cases could be the same, because the code that processes that is going to have to be updated no matter what. So it's just updating it at what I would argue is a more appropriate layer. There does not seem to have been an appetite for this, but I struggle to understand why there's an appetite to completely violate JWE in order to achieve these ends, but not to do something a little bit better, a little bit clearer. If there's not the appetite to that, I would ask that we actually update RFC 7516. It's been said several times that it's updated, but it's not. If you look at the document, it doesn't update anything, update if approved or anything. So that construct hasn't been done. And more than the tooling piece, you also need commensurate text that describes what the update is, not just the exception, but the update to the actual framework underneath. Once you started doing this, when you're updating it, you can make changes. You might realize that ink no longer becomes relevant or necessary in Internet Explorer mode. And it could just go away under these constructs. It's not that different than integrated encryption now, but without a lot of the potential baggage that I, at least personally, think might come along with it. And I would also like to see the algs made monomorphic. I'm not even sure if that's a real word, but it's the opposite of polymorphic, which is also not the right word for the context. But have one alg do one thing, and that would come down to HPKE-0 and HPKE-0-KE or KW or whatever. Those are my ideas. I think I have before, but I will even offer to help realize some of those ideas if the working group and the authors are amenable to it. Well, yeah, I guess I'd help with any of them, but I really would like to see us do better. I had a pretty closing slide, but it doesn't say anything.
You can put it. Oh, sorry. I took away your. Sorry.
Oh, did you? Oh, you took away my privileges.
No, I was.
I got played off.
No, there's this pretty closing slide. I was trying to make sure I had control when I needed to switch.
Philip?
Thank you. I want to say that everything that Brian said resonates really well. It sits really well with me, and I'm likewise willing to help with the updates.
Do you have any suggestion of the alternatives?
A different suggestion than the one Brian presented?
Any preferences among the options?
We can talk about that on the list.
Yeah.
Hi, I'm Mike Jones. I'm here to talk about the Jose HPKE integration work. And I appreciate Brian thinking things through and thinking how we can do this well. I will start with an apology. There's one thing that's wrong in my slides. While the spec says that this specification updates 7516 in a certain way, which you can find in the text, because of probably my ineptitude with Markdown, while there's an updates clause in the source, it hasn't resulted in the correct XML to do the updates in the header. And we missed it. It's certainly the intent that draft 11 updated the 7516 in specific ways, and they're described in the body. So with that, let's go to the next slide. So there's actually been a ton of work on the Jose HPKE spec since we last met. There's been drafts 7 through 11 published addressing a lot of working group feedback and individual feedback, as well as we ran a working group last call and addressed some parts of that feedback, others we'll talk about. There was clear input during Bangkok to not use enc.dir, but use enc.int to signal the use of integrated encryption so that there wasn't any potential confusion between two distinct uses of dir. We had already excluded some of the HPKE modes, including authenticated HPKE. The draft was updated to say why we excluded it. There's been a lot of discussion in some working groups about use of the info parameter to carry mutually known private information, as it's known in one of the NIST documents. And so it was updated to say that either the info parameter is empty or it contains mutually known private information. We got good feedback that we needed to clarify the relationship between the steps to do HPKE encryption and those in 7516, the same ones that Brian put on his slides. An attempt has been made to do that. Can it be done better? Perhaps. We corrected the examples. And this last bullet is what I apologized about. We thought we updated 7516 in the header to allow enc.int. I'm going to have to find somebody who knows cram down better than me to figure out how to actually do that when we publish 12. Then we ran a working group last call. The good news is there was active participation by a lot of working group members, including Brian. And 9 and 10 addressed a lot of the working group feedback. Some of it we didn't. We will talk about that in subsequent slides. 11 was largely just editorial. The other thing that's not on this slide but is important is Karen as Jose chair and me as Jose chair ran the working group last calls for the Jose and the Jose HPKE integrations in parallel and encouraged people to comment on both specifications, and some of that happened. It's been an explicit goal of the authors of both specifications, some of whom overlap, to keep them semantically aligned, even if the syntax of JSON and CBOR are obviously different. So for instance, one of the aligned changes was allowing mutually known private information in the COSE info value. We did update the use of the encryption parameter based on what happened at the mic and in the notes at 122. The spec says that when ALG is a Jose HPKE algorithm, if enc is int, you're using integrated encryption. Otherwise, you're doing the mode that Brian is still okay with, which is where you're generating the key, the content encryption key with HPKE, and then you're using another AEAD algorithm. But we explicitly attempted to, and again, syntactically failed to, upon me checking 5 minutes ago, to update 75.6 to explicitly allow this. Did I tell you I hate Markdown? No, that's a different discussion. I will say also the authors have been holding regular calls, which has been really helpful every week. And that's part of how we've made so much more progress since this last 4 months than we had in the previous ones. So there's a few questions which we do not have, I think, consensus results from, and so we didn't do anything with them in the spec. But we're going to try to work on that together today with the help of the chairs. And also, it's the case, just as an asterisk, that COSE HPKE, including Hannes, received some feedback on Monday during the COSE document that may cause a semantic change, and we probably want to do the same semantic change to the Jose HPKE. So here we go. There is 3 decisions that I would like the chair's help with, all rooted in feedback that we received during working group last call. Again, put the asterisk on the first statement because it was our intent. That it is the case that Jose HPKE attempts to update 7516 and says in the body of the text that it does. The Jose HPKE specifies deltas to 7516 JSON Web Encryption to enable the use of HPKE with JWEs. Now, some reviewers suggested that instead we should obsolete 7516 entirely, which would mean de facto we would have to suck all of it into the HPKE draft and interleave the different parts of the text so as to leave all of JSON Web Encryption working, but to intersperse the new stuff you can do with HPKE among it. By comparison, and another thing we did this week, the OAuth working group decided with the RFC 7523 BIS document not to do that because it hid the changes. Instead, we decided to only publish deltas in 7523, what Brian called in his slides in Bangkok, let's do patch, not put. And indeed, that stuck. And that's where we are with the Jose HPKE right now, where you're doing patch, not put. So speaking as an individual, unless there's a clear consensus to instead suck all of JWE into this document and intermingle them, I would propose that we leave that as it is, but I would like a formal decision from the working group about which way we're going to go. Because two people did say during working group last call, or you could do a full obsoletes replacing it. Karen.
So is there any questions or discussion on whether or not we should ask this question? All right, seeing nobody in the queue, I have a hand. Oops, sorry about that. I asked all three questions. No good helps hard to get.
First question, if you missed that, will be shall we update? So you can think about that until it gets posted. Now it's on. Seems very clear.
Anybody need more time? Nope. All right. People are changing verbs.
Brian?
Yeah, I think update is a viable and likely outcome, but I would just reiterate that I would like it to actually update both in the tooling and content throughout.
Yeah.
So
Yeah.
Agreed.
That seems to have been a mistake in the draft.
Yeah, I blew the mark down.
There's also content and semantics and all the other stuff. And so the current approach is a little bit, maybe just wanted to qualify.
Yeah. Thanks, Brian.
Okay, thank you, chairs. Decision 2, and there's a lot of history in this one. The Jose HPKE draft at different points has used 3 different syntaxes to signal the use of integrated encryption. And Brian is absolutely right that integrated encryption doesn't fit let's say the phrasing of encryption that we did a dozen or so years ago with 7516. And the reason it doesn't fit is every encryption algorithm that existed at that point that we were aware of did it in 2 steps. A key establishment step, and then a content encryption step. One of the innovations in HPKE is that you can do them together into one integrated algorithm. And indeed, for instance, TLS encrypted hello, that's what they're doing. They're doing integrated encryption. There's lots of places throughout the IETF that the ability to do integrated encryption is being utilized. And so nonetheless, to make it fit into the JWE framework, there has to be a way to say, this is integrated encryption. It's not your father's JWE. We've used ALGDIR. People hated that for good reasons. think rooted in some of the confusions that Brian said could happen. We used EncDir, which is maybe not quite as confusing, but still you might have code that thinks it understands dir and gets it wrong. And so in Bangkok, people said, just use a different identifier. So we chose int for integrated encryption. And that's what's currently in the draft. Now, during working group last call, I will say one reviewer even suggested a variant of one, which is we do algint and we move the integrated HPKE encryption algorithm to the enc field. So again, speaking as an individual, unless there's a clear consensus to use an option other than what's already in the draft as a result of the feedback from 122, I would propose to leave the syntax for signaling integrated encryption as is. Chairs, take it away.
Any questions or discussion before we ask the question? Go ahead, Philip.
I don't think this is a yes or no question. It entirely depends on what the actual content outcome of decision number one is going to be, and whether we're going to take some of the feedback that Brian presented to heart and actually have, for example, different HPKE algorithm identifiers that one of them means integrated encryption and the other one means key negotiation or whatever the mode is called. So I don't think we
So
can
you think
answer.
it's premature?
I think if you ask me yes or no, it's a no, but it could be yes if we actually make changes other than limiting ourselves to whether we put int into alg or enc. So it's jein, auf Deutsch. Sorry.
Joe?
Yep, Joseph Heenan. I mean, I'm not sure I'm 100% following everything, but didn't Brian suggest an alternative option for that? And I think he did, so shouldn't we be considering that option as well here?
Tiro?
Irrespective of the option that we pick, right? I mean, I don't see how it's going to be dangerous or would cause a security degrade, because HPKE mandates A8 algorithm to be used. You can't do null encryption, right? As long as you're picking to the full cipher suit, which says that you have to encrypt the content and it has to be encrypted by the HPKE cipher suit specified A8 algorithm, right? I don't understand the challenge of how it's going to be dangerous, how it would cause a degrade attack, that somebody would send some confidential data and some implementation would magically put it as a plain text and not provide integrity and confidentiality, right? If that attack is there and how it's going to be evident, I have not seen any examples or concrete proof other than some implementation doing it in the wrong way, but implementations always make mistakes basically. But how is this gonna, I mean, we pick any of these options, how is HPKE integrated mode gonna cause a downgrade attack, right? If that could be explained, that would be wonderful.
Leif?
Do you want to get into this now? No, well, because this seems like a. Go ahead.
Completely honestly, did you watch the presentation I had before Mike's? Because I did try to explain it. I might not have done a good job. Yeah, absolutely. I stretched it, and then I jumped into, because the mitigations might come from maybe I didn't use it then, but the atrocity being committed on the other layer. So it's not about a downgrade on HPKE itself. It's about this stuff that you're putting into or on top of JWE, having to live in the constructs of real systems that are already doing JWE now. And the introduction of this when used in conjunction with other existing algorithms, introduces the potential for confusion between the application layer and the JWE layer that currently consider something like dir plus an AEAD cipher, all of them are, as a integrity guarantee and treat that as a signed token. So when you come along and you put along, not you specifically, although all of us, when you add a null cipher into that on top of systems that have an assumption about both confidentiality and integrity coming from that layer, it would be a mistake in the code, but we shouldn't be allowing, we shouldn't be enabling mistakes like that to the extent that we can. You introduce the likely possibility that an implementation gets confused and sees int, treats it as an AEAD because that's what they all have been before. That's what that thing means, and allows for a bypass, not of HPKE itself, but of this layer that's trying to map HPKE onto or into Jose. Does it make any more sense?
We only have 10 minutes. We should try to finish all the decisions.
All right, so Leif Johansson. So I must confess, I don't care an enormous amount of this, right? But I was one of the people who reviewed and said I think it was fine. And now I recently went just for the hell of it, went back and checked 7516 language in section 412, and it says about Enc that it identifies the algorithm. It isn't, the language isn't actually very specific as it is today. It doesn't say that it points into a specific IANA registry or anything. It says that it identifies the language. I think if you're squinting at that language, you could claim that the use of int there is not actually violating. It's certainly violating how people have chosen to implement it. I understand that, right? And I think the danger is in how, you know, current implementations would interact with this and how much you would have to respin your code, et cetera. But I think it might even be a good idea to clarify the language in 412 and possibly 411, just because it is unclear as it is today, right? Which means that you're right, but I think technically I'm not entirely sure that you're correct when you say that it is a violation of the semantic.
Joe? Oh, you got it. Sorry.
Joe Salloway. So just going back to what you said, like in some ways it's great that the text may be, or the text is ambiguous, but what you said that may be important, and I haven't looked at the implementations, but if the implementations are such that this confusion can happen, then that's a problem regardless of what the spec says, and we need to be aware of that. Now, I don't know if that's the case.
All right,
but
so
just to finalize that thought, I think the reason I said this is fine is because I think that the implementers actually do understand what they're supposed to do.
All right.
But you know.
So for the purposes of the last 7 minutes, I'm going to run the poll that Mike has asked for. And if you think it's too early, answer no opinion, and that will indicate to me that it's too early.
Showing up.
I can't think of the game show tune that's da 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 da. All right. Has everybody had a chance to vote who wants to? Okay. Thank you. All right. I don't think there's any consensus on this one, so we'll have to continue. I'm sorry, Mike.
Okay. Third decision. Richard Barnes suggested, who was a collaborator on this in the very beginning, Well, rather than having integrated encryption feel like a special snowflake that's kind of grafted in from the side, maybe we define a new JWE key management mode, which integrated encryption is the first instance of that we implement. For context, the existing key management modes are key encryption, key wrapping, direct key agreement with key wrapping, and direct encryption. Those of you who are implementers know what those are. This would add a sixth one, which he suggested calling direct public key encryption as opposed to direct encryption. Direct encryption uses a symmetric key. Direct public key encryption uses public key cryptography. That's a reasonable architectural suggestion. It's a fair amount of editorial work. I am willing to do that work. So without further ado, unless there's clarifying questions, I turn it over to Karen.
Clarifying questions? No opinion, what? Oh.
Is no opinion similar to the last poll where it's too early and or this question is kind of obsoleted by potential suggestions from the priors?
I don't know what no opinion means in this context.
Okay.
I guess I wouldn't say I don't know. I hadn't.
I have no opinion.
I originally wrote these questions when I'd forgotten it was yes, no, no opinion. And so I had lines and then the lines didn't match the.
Tool's not letting me say no opinion, but okay.
So you have no.
Very quickly, I think.
I mean, go ahead, Philip.
Thank you. I think in a way this is going to force the update of 7516 to be more substantial.
I agree.
And in that way,
and better integrated.
And in that way, we may actually explore additional options.
Yeah.
All right. So I think we had a clear answer on the first one, and then the first question, the second two questions were a little bit more ambiguous pending the update.
I think I, at least as an editor, and probably Ori, take away that we should try to do the new key management mode and see what that looks like as a published draft.
Okay. Okay, yeah, that's great. Let's take it to the list.
Okay.
We have, do you need these or can I go?
Yeah.
Can I close up?
You want me to do this slide or you want to say something?
I was going to talk about the guy who's not getting to present, so.
People are talking.
There's one more presentation that we missed. I wanted to talk about it.
Okay.
So if you like 30 seconds, you've got it.
Okay. This was my last slide. Where the editors came to when preparing this presentation is we believed that if we got decisions from all these things, incorporating coordination with COSE, taking into account the possibilities that Brian's talking about, I think we're on a path to finish, which is a good thing. I mean, the IETF is banking on HPKE as the way we're doing encryption going forward, including post-quantum encryption in many cases. And so we want to bring that goodness to Jose. Thank you.
Okay, go ahead.
Can I do one small, ask for a small favor of everyone? We are all banking on HPKE for our future encryption, goodness and joy. If you have any favors to pull with browser vendors, please ask them to start working on an HPKE interface to be able to use it from JavaScript. It doesn't exist today. There is no work in progress on it. Before we get it, composites may as well be obsolete.
We should talk to Simone about rechartering web crypto then. He's here.
So Lucas, if you can do like 30 seconds on what you want people to do. I know you can't go up through all your slides. I'm very sorry. But if you can tee it up for the mailing list.
Yes.
Thank you.
So very quickly, this is about the draft post-quantum traditional hybrid composite signatures for Jose and Cose. So it was presented at IETF 121, but we have done in the past few months a few updates. So very quickly, now we only support the seed representation for MLDSA private keys. We changed the key type to AKEP. We added Jose test vector, and we align with the LAMPS composite draft. So yes, we have several works right now at the IETF registering composite signatures, and they all try to align with the LAMPS composite draft. So this is also our case. So as a reminder, this is the 3 composite algorithms that we currently register. And if there is interest, we could register more in the future. So we align with the LAMPS composite construction. So here are the 3 algorithms. And in particular, we are making use of the serialization subroutines defined in the LAMPS composite draft to produce the byte string encoding. And we construct the message representative in a similar way as the LAMPS composite draft. So here I detailed the construction, but I don't really have time. So yeah, let's skip this. So we also added the Jose test vectors. And finally, I think the draft is ready to proceed to a working group call for adoption. And if you have any comments or suggestions, thank you.
Right. Obviously, we're not going to do a call for adoption here. I'm going to I'll send an email to the mailing list asking for everybody to review your document, and then we'll do a call for adoption after we get some feedback on whether it's ready, if that's okay. Thank you very much. I'm sorry we cut you so short. All right. Thanks, everybody. Have a good evening.
Yeah,